Welcome to the Embodied Carbon Network 2018 webinar on LCA data and tools. We're going to pause for about a minute and start once more people have had a chance to join. Well, hello again. This is Kate Simonen. I'm an associate professor at the University of Washington and director of the Carbon Leadership Forum, the convener of the Embodied Carbon Network, and I'm moderating today's session, Embodied Carbon in the Built Environment, Lifecycle Assessment, Data and Tools. This is the final session of a 6-part webinar series, and we have several exciting speakers joining us today who will discuss lifecycle assessment methodology and data, and provide overviews of current LCA tools used by industry practitioners. Please note that this webinar is being recorded and will be made publicly available upon completion. Many of you joining today are already members of the Embodied Carbon Network. We do have guests in the audience who we invite to learn more and join the network. The Embodied Carbon Network is a communications and knowledge sharing platform that was launched by the Carbon Leadership Forum in January of 2017. The network brings professionals working in or with the building sector together to share news and resources, engage in discussion, and develop educational content. The network has evolved into a vibrant, engaged global community. To date, we have over 360 professionals from across the building sector, academia, nonprofit, and government groups representing over 90 cities across the world. We are brought together under a shared mission to eliminate the embodied carbon emissions from the built environment in order to meet global greenhouse gas emission targets by 2050. The network comprises 10 subject-specific focus groups, which members can join for additional engagement around a topic related to embodied carbon. The Embodied Carbon Network is funded and managed by the Carbon Leadership Forum. The Carbon Leadership Forum is an industry academic collaborative based out of the University of Washington that carries out research, education, and outreach activities focused on embodied carbon emission tracking and reduction. So thank you to our sponsors for supporting the Embodied Carbon Network and the 2018 webinar series. Again, today's webinar is the final session of a 6-part 2018 series, and each topic is based off of network focus group topics. Network focus group chairs have worked with their groups to identify speakers and develop the curriculum for each session. The webinar series is part of our goal to increase knowledge and provide educational resources around embodied carbon emissions in the building sector. There's a depth of knowledge and expertise brought by network members, and the webinar is part of an effort to leverage and translate this knowledge more broadly. Our goal is that each session will not only be useful to live participants, but also serve as free educational resources for anyone interested in learning more. Please feel free to share the webinar recordings with your colleagues, professional networks, and students. And if you are an AIA member in need of educational credits, this course is eligible for live attendees to receive credit. As a disclaimer, the mention of trade names or commercial products does not constitute endorsement or recommendation for use. And please note that the opinions, ideas, products, and data presented by the speakers in this session do not represent the members of the entire Embodied Carbon Network or constitute endorsement. Our goal is to introduce topics that could help participants think and talk about the building industry strategies for reducing carbon emissions attributable to building materials. So today's LCA data and tool webinar will introduce 6 presenters and a question and answer session from 10 to 10:15 or at the end of the hour. Please submit your questions through the GoToWebinar question function, and we will track and direct them to the appropriate speaker at the end of the session. Note that this webinar is designed to provide a broad overview of LCA data and tools, and we have only a short time for each of the speakers. We'll be moving quickly, and they'll each provide links for additional resources. So we're joined today by Jeremy Gregory, who will describe the landscape of LCA data and tools in North America. Following Jeremy, a panel of speakers will present on various LCA tools available to building industry professionals to support project decision-making. These include Jennifer O'Connor from the Athena Sustainable Materials Institute, Panu Pasanen from BioNova, Laurel McEwen from Climate Earth, Roderick Bates from Kieran Timberleek, and Stacy Smedley from Skanska. So now I'd like to introduce you to Jeremy. Jeremy Gregory is a research scientist in the Civil and Environmental Engineering Department at MIT and the Executive Director of the Concrete Sustainability Hub. Jeremy?
Thanks so much. It's a pleasure for me to be here, Kate, and to kick this off, as you mentioned, by giving an overview of life cycle assessment data and tools with a specific focus on North America. If you hit the next slide, I think a lot of us look at data and tools to try to understand, specifically answer a question about what is a green building. And if you could hit the next one, fundamentally, the reason why it's important to use a life cycle perspective is because there are many different strategies that can be used to limit environmental impacts in building designs. And here are just some examples in the couple different life cycle stages that we usually use to characterize buildings, whether it be materials and products or design and construction, operation, or end of life. And each of these on their own could provide environmental benefits, but the important thing is that we need to look at trade-offs among them and evaluate those quantitatively. So if we take action in one category, it may actually have implications on another category, and it's important to look at those together. So next slide, I have an overview of the tool that we generally use to quantify those environmental impacts, and we call it life cycle assessment. And essentially what we do is we break down each of these different steps in a building life into different processes. And that's what's meant by those little rectangles there. And within each one of those, what we do is we quantify all the inputs to a particular activity, usually in the terms of energy or raw materials, including water, and then also releases to air, land, and water in the form of emissions. And so we track those throughout the entire life cycle. And then we can summarize those environmental impacts using different metrics that might focus on particular elements of that, say air emissions that contribute to climate change, or emissions to land that might affect ecotoxicity, and on and on. So next. Now, within the building community, there has been quite a bit of work done to try to get some conventions to allow us to use a similar language when it comes to life cycle assessment. And a common standard comes out of Europe, the European standard EN 15978. And essentially, it's broken down the life cycle into those 6 broad categories that you see at the bottom there: production, construction, usage, operation, etc. And the letters and numbers below them, A1 to A3, and etc. Though there are even more specific categories that I haven't included here, just to not make it too cluttered. But essentially, they get more specific about particular elements of the life cycle. The other thing that I've tried to do here is on the top part there is be specific about how some of the categories are more relevant to building products. And so for those categories, you sum up impacts across production and construction, and then usage of building products, whereas some of them, specifically B6 to B7, are more about operation, and particularly about energy and water. So that's a convention, and you'll see some of the other speakers actually refer to some of those letters and numbers in their presentations as well. Next. And the other thing that I wanted to emphasize is that there are different types of building LCAs that are currently being done, and they have different scopes. And that's primarily because they're intended for different types of purposes. So the one in the top row there, building product EPDs, or environmental product declarations, that's essentially a life cycle assessment that's done on a specific building product. say like concrete or wood or steel, or it could be flooring or cladding or all kinds of things. So those are being used. You'll also hear reference to whole building life cycle assessments. And as you can see here, that constitutes the materials and production, construction. Usage here is meant to be like if there's a replacement of building products or maintenance throughout their life, and what happens to them at end of life. And this is contrasted with whole building and whole life LCA, which includes the operational phase as well, like electricity usage or water usage, things like that. And the terminology on that last one, there's a couple different opinions, and I, to be honest, I don't have one that I like the best yet. But it's just differentiated from whole building, which actually is just on what we call the embodied impacts of the building in the materials and the construction. So next. And a big driver for particularly for the environmental product declarations and the whole building LCA has been the LEED standard. And so what I'm showing here are the different categories with which you can get points within LEED, and in particular in the materials and resources category is where there are points available for projects that use EPDs or conduct whole building LCA. Now, within that M&R category, the EPDs, basically a project gets points for selecting vendors that have EPDs, but it doesn't specify how the EPDs should be used to support decisions. Right now, it's purely meant as a mechanism to try to encourage people to quantify the environmental footprint of their products and report it. Whole building LCA can be done to demonstrate environmental impacts of reductions of impacts in building design compared to a baseline. So that's encouraging to see LEED has incorporated this. Next. Now, just to come back to the scope right here, as I mentioned, the building product EPDs are used to satisfy those points, and so are the whole building LCA as well. So next. Now, as I mentioned, the EPDs right now within the LEED standard aren't being set up specifically within that standard for comparison. But when it comes to EPDs generally, and they're used for all kinds of different products across the world, the intention is that we would have a measurement system by which we could do comparison. And similarly, just about any LCA, you want to be able to compare among different alternatives. And so what we just want to make sure is that we're comparing things that have had similar ways of doing measurement and reporting, so we can make sure we're comparing apples and apples and not apples and oranges. So next. And so coming back to the scope of doing these different types of LCAs, some of the objectives that we might have, for example, for evaluating building product EPDs, is we might want to make vendor decisions. That is, we already know what kind of products we're going to use, but we haven't selected specific vendors yet. So an EPD could be a mechanism that you use in order to help you support that, because an EPD is reported by a specific firm for a specific product. And contrast that with LCAs. If you're doing a whole building LCA, you can use it to compare alternatives if they have the same operational performance. So you can extract that out if you're confident that the energy consumption and water consumption of the alternatives is the same. If you're comparing among different alternatives that have different operational performance, then you would need to do a whole building and whole life LCA to make those complete design decisions. So I think this is important to keep in mind about what are the objectives for using EPDs or building LCAs more broadly, beyond just how they're being used in LEED right now. So next. Another thing that I want to mention when it comes to this comparisons is it's important to think about what type of data is used in life cycle assessments. And generally, what we call the data that goes into a life cycle assessment is a life cycle inventory. And these are basically the data that I mentioned earlier about energy consumption, material consumption, water, and emissions to air, land, and water. So there's a lot of detail that goes in. This diagram right here is from the ILCD handbook, which is basically a handbook for how you would conduct an LCA put together by a group of stakeholders. And what they differentiate is what they call a foreground system and a background system. So the background system is generally, upstream processes like transportation or energy production or, certain types of material production as well. Whereas the foreground system is usually the system that you're particularly interested in. So if you're doing an EPD of a cladding material, the foreground system would probably be the manufacturing of that cladding material, whereas the background system would be other elements that are used upstream from that facility, but would still account for their environmental impact. So I'm going to be talking about that background versus foreground data. So next. Okay. Now, when it comes to environmental product categories, there are a lot of different rules that can be associated with how a life cycle assessment is done. And a product category rule, or a PCR, is what's used to help ensure that EPDs follow the same rules for how they do their calculations in that foreground system. And so they're specifically set up so that when we have an EPD, that they have tried to follow at least as much of the same rules as necessary. Now, within those EPDs, the EPD is set up as industry specific generally. So, we have an EPD for concrete materials, for wood materials, steel, cladding, etc. And some of them may specify the type of background data that's used, but some of them may not. And as a consequence, that can mean that even if they've generally followed the same PCR, they may or may not actually have the same type of data that's used in the calculations. So next. Another thing to keep in mind when it comes to these comparisons is that there's a lot of things you have to check for if you're going to do comparisons among EPDs. This bulleted list that I'm showing right here comes from an ISO standard that's specifically geared towards how you calculate and report EPDs. And as you can see, there's 11 different items here. It says that you need to check before doing comparisons. And these elements are related to scope, data, and models that are used in both the foreground and the background. PCRs vary quite a bit, and some of them may include these elements and some of them may not. But it's interesting in looking at this standard, it says a big motivation for setting up EPDs is that we can do comparisons across people who are essentially doing different LCAs. But they also really stress you need to be very careful about looking at these elements in particular when doing comparisons. Next. There's been some interesting research that's been done on comparisons of EPDs. And in particular, this study right here came out of a university in Toronto where they compared EPDs for construction products. And they specifically looked at insulation, flooring, and cladding. And what they did is they did comparisons on a whole bunch of different characteristics of EPDs. But what's interesting is that within their comparisons, they found many different factors that would lead to essentially what they called invalid comparisons, and using that ISO standard for guidance. And basically, in some cases, they had different functional units or the basis by which they were doing comparisons. They were using different factors for calculations, had different rules by which they were doing cutoff or allocation. And so it meant that, as you can see at the bottom there, about 61% of comparisons were considered to be invalid. And what I think there's some additional research that needs to be done to kind of see, to what extent does that mean numbers could be off, and how does that change depending on the particular type of environmental indicator that we're interested in. So next. And then the other thing that I wanted to mention is that EPDs are not life cycle inventory data. And so we need to be careful if we're going to be using EPDs in whole building LCA. They don't report the type of data that you typically need in an LCA. And so there are a couple things we really need to keep track of about if that is going to happen. And I've listed those at the bottom there. So next. The other thing is that we have a report with a link at the bottom there about some critical issues that need to be considered when doing comparisons for building LCAs as well. And so I just mentioned this as kind of something to follow up on, but just as important for considering comparisons. So next. And then the other thing that I want to mention is that when it comes to design decisions, which, as I mentioned, is an important element of doing LCAs, they may or may not actually include EPDs. And that's partially because when you're early on in the design process, you don't necessarily want data from specific vendors. EPDs are created to support more vendor type decisions, whereas early design decisions may or may not include that. So I think what we want to do is try and find high quality and industry representative data that can be verified. And so there's actually a couple different database efforts that are underway to try and create this. One that I've been leading up, the North American Lifecycle Inventory Data Center, and one that's out of Canada that's led by Jeffrey Guest, and it's for a national low carbon infrastructure initiative. And right now we're working on trying to see if we can merge those into one. But that specific, consistent background database is what's needed to try to achieve that. So here's a list of some publications that kind of have some background on what I presented, and that website at the top can be used with additional information. So that's it.
Thank you, Jeremy.
You're welcome.
So now if I can get the slides to advance, I'm going to introduce Jennifer O'Connor. She's been the president of the Athena Institute since 2011. And is a member of its board since 2000. The Athena Institute is a nonprofit research group that advocates for environmental performance measurement and accountability in the built environment. It does that by enabling the adoption of life cycle assessment in the construction sector, working with material manufacturers, architects, engineers, green building programs, policymakers, and research collaborators. Jennifer?
Alrighty, thank you, Kate. And thank you, Jeremy, for that excellent background. I think that was really helpful for the rest of the webinar here. I appreciate that. All right, let's get right into the first slide, please, Kate. Before I can talk about the impact estimator software, I have to give you just a little bit of sorry, 1 second. I just have to, okay. Oh my God, I'm sorry about that. Had a phone call come in. Okay. I need to just give you a bit of context, and that's because the Athena Institute is not a software company. It's not what we're all about. Our tools are simply a vector to a tactic for us to deliver on our mandate. And our mandate is to advance the science and uptake of LCA for the built environment. We're a nonprofit research and advocacy group, been around since 1997, but the work actually dates back to the late 80s. As LCA consultants, we've done hundreds of studies on products and materials. We're very active in the EPD world. We do a lot of peer reviews. In our public service work, we do a lot of LCA-based research, provide a lot of information and policy support, things like our whole building LCA guideline. We sit on LCA standards committees and so forth. And of course, we provide free software tools, which have enabled inclusion of whole building LCA in the green building programs and policy. Could I have the next slide, please, Kate? Now, the impact estimator was launched in 2002, and it's continuously updated. This is PC desktop software, but we've got a workaround solution for the Mac users. The software was originally meant as a learning tool in early design, but it can be used at any stage of design or for any type of building. It can be used for whole buildings or parts of buildings. And it delivers full cradle to grave results, either A to C or A to D, depending on the user's choice. A lot of reporting options. The sample I've put up on the screen is one of its more powerful features. That's the ability to compare projects side by side, because that's what LCA is all about. It's all about comparing options. Now, it's not a slick tool, and we're okay with that. Our resources are really limited, and we tend to focus on data quality and methods. Next slide, please. I've got a diagram up here of how the software works. I know this will be hard to absorb in the 30 seconds it'll be on your screen. You can find this diagram in our software documentation, along with all of the details on our data and methodology. But basically how this works is we get some basic information from users, and that helps us regionalize results, and that will affect the scenario data. And then we need a bill of materials. Users can let the software calculate that for them, and that's how the tool is useful really early in design. But users can import a bill of materials if they wish from another source, as long as they're aware that some material quantities may be missing from those sources. Then that information is taken into the back end, which consists of our own high quality, highly regionalized US and Canadian material and process data, and our scenario databases. Scenario is LCA speak for the data and assumptions that we need to fill out the cradle to grave analysis. Jeremy mentioned some efforts underway to establish new national or continent-wide databases. We're very much in support of that. We would participate in that, and we would transition our software accordingly. Next slide, please. Just another example of what the output can look like from the tool, and gives me a chance to mention a couple of things that we're working on. We are headed towards a web version of the tool, which will be beneficial for a lot of reasons, but also makes it possible for us to partner with third-party software. We're very open to that. In fact, we've got one partnership about to get underway, and that's going to be our pilot for how we can make that happen. Next slide, please. Wanted to just give you a glimpse of our other free software tool. It's called Pavement LCA. This is for paving projects like roadways. It's a web application that we originally launched in 2013 as a desktop tool. We've just continued that, and it's web only. This works just like our buildings tool, providing cradle to grave LCA results, drawing on our US and Canadian LCI and scenario databases. And in addition, this tool has the life cycle costing, which is kind of neat. The modeling for that, as well as the model that we use for payment vehicle interaction, came to us from MIT, and we're appreciative of how much those pieces strengthen the tool. Next slide, please. I wanted to take my last minute to highlight some of the pressing issues in whole building LCA and what we're trying to do to help address them. One is the problem with comparability across whole building LCA studies, and that's the crux of the issue if we want to establish performance targets. So that's a critical next step for policy and program support. So to help tackle that, we've got a benchmarking initiative underway, and I know others are thinking about this too, like the SCI Sustainability Committee, and we've been putting our heads together on that big issue. The next issue, and very much related, is standardizing the practice of whole building LCA. It's something we're big advocates for. We're taking a run at demonstrating how that's done with something that we call environmental building declarations. And that's where we're showing how to do whole building LCA and consistently report results following a standard. It's kind of like an EPD for a building. And in that sense, that effort then is also about transparency. The third issue, and one that I personally think is perhaps most important right now, is user education. And that's because it's easy to make a mistake with whole building LCA, like misinterpreting results, being overly confident in results, and ending up with unintended consequences. So I'm wondering if education is something the ECN could collectively tackle. We've given a go by putting together a full day hands-on workshop a number of times, but we could use some help. Next slide, please. And it's my last slide, just on give you a sense of what you can find if you wander over to our website. So all of the information and user guides and links to the software and our transparency information is all over there. We have a whole series of very short video demonstrations, get new users of the software up to speed quite quickly. We have a lot of publications, our material LCA reports, our environmental building declarations, our guide to the LCA provisions in the green building programs, links to get on a link to get on our mailing list, which I would really encourage. We will not spam you, I promise, and information on how on what we're all about in our mandate and how to support us. I'm all finished, Kate.
Great, thank you very much, Jennifer. I really appreciate that. We'll pass on to Panu Pasanen. He's the CEO and founder of BioNova, the world's leading lifecycle performance software company for the construction industry. He is leading the teams developing the innovative one-click LCA platform, allowing energy modelers, architects, structural engineers, consultants, and other experts to use their design packages for automated carbon, LCA, and life cycle costing studies. Tanu?
Yeah, thank you, Kate. So one-click LCA is a cloud-based software, and we have started with the ease of use in mind. And what you see here is a typical screen where a few alternatives have been considered, and where the user is using a lead for workflow. So the software is built around guided approach, so you can do the steps properly. So you don't have to know everything. You can take guidance when you need it, and you can do things in a structured manner to ensure the results are correct. And when you repeat the process several times over different projects, you will be able to repeat it, making consistent documented decisions over time. Next slide, please. Next slide, please. Right. So I go back here to what Gregory said about when should you do what. So we actually started with looking at how do people work in the earliest phases, and when you should. So go to the carbon designer slide, please. Now I see again my first slide. Yeah. The first possible time when you can influence materials design is actually the strategy. So when you work with the investor in the very early phase, when you design whether you want to do a high building, for example, or a lamellar building, like elongated mass, those kind of decisions you can't do them later. And that's why we started looking at what is the right solution for that stage. And we developed a module called Carbon Designer, which allows you to generate for 11 different building types for hospitals, offices, prisons, retail, residential, a building mass with typical constructions, which allows you to vary those constructions, which allows you to adjust those constructions very early and very fast. The point is that you can take the right direction. It's not about making an exact choice. It's about choosing the direction of travel, so to say, with regard to materials design. It can be used to generate a baseline building, but the point is really to find the best solution from a materials carbon point of view. You can use it with simple geometry, or you can use it with complex geometry. And you can change structures, or you can change materials, adjust recycled content, and generate a complete bill of quantities. And I think this is the probably the most important single thing, because every decision you make here is 10 times more powerful than any decision taken at a later point in time. Next slide, please. So when the design advances, and when you already have reached a point where you know something about the building, how it will look like, how it's going to be laid out in detail, what structures you will use, you certainly will move to using some design software or the other, or several more commonly. And what we have done to enable productivity for the end users who do LCA, and also to simplify the life, we have developed several plugins. So we have today 9 integrations on the market. We have a Revit plugin for all Revit versions. We have IES and Design Builder, which are the most common commercial energy modeling software in North America. We have integrations with those. We have also spreadsheet integration, of course, Solibri, and others. And the point is that you can use the data you have invested in, you can work in the environment that you usually work in. So it allows different disciplines to actually use Carbon as a design tool. But you can also do it completely in a browser. This is just a alternative way of speeding up the work. There's an algorithm which will automatically pick out the materials that seem to be the appropriate choice, which is learning about your labeling conventions. But you can also map the data to specific choices if you happen to already know what exactly are you going to use from an EPD database. And all the options, you can generate them online, so you don't have to change anything in the Revit model or in the energy model. You can just generate a stream of options online very easily by varying just the parts you actually are interested in varying. And if you're not an expert, we have several tools to help you. So we have a model checker at once to make sure that the model doesn't miss anything essential, or it doesn't have anything too much either. And we have an LCA checker, which makes sure that you are not missing stuff. So you have proper scope in terms of, for example, lead scope, or just the otherwise the complete building scope as measured by uniformat, for example. Next slide, please. we get to the finally to the point of specifying materials. Could be a bit earlier, as done by the architect, but could be also something where the construction company is looking at the different options when meeting still the specifications given. And we do integrate pretty much all the North American EPDs. We also have a range of generic data allowing you to model the whole building using generic data. But the EPDs are, of course, an important thing because this allows you to actually justify choosing a better product. You can still influence the carbon performance of your project just by buying better. And we allow you to use public EPDs, but you can also add private EPDs by sending them to our support team. They will check it, and if it's passing the QA checks from our side, it goes to your private database, and you will be able to use them as well in the assessment. And you can see here in the screen a glass full benchmark against the market average and the product you have selected. This allows you to instruct your decisions in procurement, so you can look at the different products. This is right. So yeah, we have private constructions and stuff. Okay, so maybe you can skip to the next one. I think that was my cue for moving to the next. So we are selling the software in a pretty wide variety of markets in the United States and 55 other countries. Our main client sectors are engineering, architecture, and then we have investors, construction firms. And some of the projects I just will mention the Bloomberg's European headquarters because it's been dubbed as the world's most sustainable office. So of course it sounds nice, but we have also a lot of more standard construction processes using the software. Next slide, please. So one-click LCA is clearly a tool for a more demanding customer. What we try to do is to enable saving labor time and enabling complex decisions to be made with the actual information. So we don't want to have limitations for our customers. We want to enable making actually the decisions that you need to do to justify making a big commitment in changing a material or so forth. The software is of course costing money, but that's pretty much nothing compared to the differential between material cost that you have to justify in a real project. So we have a third-party verified calculation engine. It's compliant with EN 15804, 15978. PRE has checked it. A bunch of other people have checked it. We do provide training. We do have workflows to support you if you work with lead or not. And we have a very good customer support team staffed by LCA engineers who always respond within 24 hours, usually in about 2.5 hours actually. And then there's a lot of different tools from LCA to documenting EPDs, doing circular economy assessments, life cycle costing, and so forth. And there's Smith Gill are doing some of the biggest buildings in the world, and well, we are very proud that they choose to work with us for one. Next slide, please. Then we have some resources. Yep.
Okay, please just wrap it up then now, Panu.
Yeah, okay. So you go to our website, you find a bunch of resources. The Embodied Carbon Review is something we published this week. It's a very nice paper on the global use of embodied carbon. Thank you.
Thank you. I second that. It's a really interesting read on policy practices in embodied carbon. Let's see. Now I'm transitioning to Laurel McEwen. Laurel is the Vice President of EPD Services at Climate Earth. She is a life cycle assessment practitioner with over a decade of experience working with Fortune 500 executives on PCRs, EPDs, and strategy for the use of LCA. Laurel.
Thank you, Kate. I'm going to share a suite of 4 applications that are helping the building design community reduce concrete's embodied carbon in new construction projects. The suite is based on Climate Earth's rapidly expanding national database of comparable concrete EPDs. Next slide, Kate. These EPDs are being calculated and published by the EPD generator, which we launched about 3-4 years ago and is the first application in the suite. This application is compliant with the North American Concrete PCR, it's third-party verified, and companies can use one of 2 program operators to publish their EPDs, NRMCA or ASTM. Plants using this generator have all collected their primary LCA data and can calculate and publish the EPD for new mix designs within minutes. Now that our database of EPDs has grown to over 20,000, we're able to offer the building design professionals analytical applications that use this data to support their environmentally conscious building designs. And it's also helping concrete companies accelerate innovations in low carbon concrete. Next slide, Kate. The first application is the Concrete Selector. This is a free tool that queries the complete database by strength, PSI, and percent SCM, supplemental cementitious materials, and it gives the possible range of embodied carbon. So you can see here the range of embodied carbon for a 6,000 PSI mix in the complete database. This allows a realistic carbon metric to be added to a concrete specification when building professionals are sending them out for bid. Next slide, Kate. The next application is the Project Builder, which queries a specific company's EPD's data and calculates the embodied carbon for the entire project. You can see here an example project that requires 4 mixes: fill, floor, walkways, columns. And based on the total yards of concrete needed for each mix type and the current EPD data for the company, the total concrete's embodied carbon ranges from a minimum in this example of 1,500 metric tons to a maximum of 4,000 metric tons. This gives the building professional a realistic estimate of what is possible for their total building's embodied carbon with that producer. Next slide. Now that the building designer can work with a concrete company using the fourth application in the suite, the Concrete Designer, in this application, the concrete company can design new mixes that meet the specific project requirements of the designer and see what actual embodied carbon results will be for their mixes. The building designer and the concrete engineers can iterate the design and view changes and impacts instantly. Once the design is settled on, an EPD can be generated. Next slide, Kate. All core building materials, concrete, steel, and wood, have different performance characteristics, but one key element of all of them that is lacking is the availability of real-time environmental data to support sustainable product designs and smart use of materials. We think the CE Enterprise Suite is filling this gap for the ready-mix concrete industry. Now I want to share with you the data that goes into the tools because that's really important. Next slide. All data, all EPDs are governed by their product category rules. One key component of the concrete PCR for the system boundary is that it's cradle to gate. This is what says what part of the life cycle of a concrete must be included in the EPD. This means that for concrete EPDs, the production of all materials used in the concrete A1 is included, plus the transportation of these materials to the concrete plant, A2, and finally the energy required to manufacture the concrete, plus waste and emissions produced, A3. You see that the rest of the life cycle is not included. So the EPDs produced can basically be considered the embodied carbon of the concrete in the building. This information can then be imported into the whole building LCA, and then the rest of the building's specific life cycle added. And since the CE Enterprise Suite is web-based and all the data is digitally available, this information can be instantly imported to a whole building LCA tool through an API. Next slide. The last thing I want to point out about the North American Concrete PCR is that it is unique in that it defines the A1, A2, and A3 background data that must be used unless material-specific data is published. No other PCR that I know of does this, which is unfortunate, as this consistency in background data is what's making the EPDs using the North American Concrete PCR comparable. So the aggregate, cement, the admixtures, the trucks, the ocean and rail transportation, the electricity, the diesel, the natural gas, the propane, the water, all that background data is the same because the PCR requires it. The other thing that is unique that the North American Concrete PCR does is to require that all EPDs list the exact source and dates of the data they're using. This makes the EPDs much more transparent. Anyone can easily look up what data was used to do the LCA to create the EPD. Two thoughts that I want to leave everyone with is that it is the PCR developer's responsibilities to specify the data that EPDs must use. And the second is that if other industries would do what the concrete industry has done with their PCR, and then also support the development of EPD tools like the concrete industry has, then it would greatly advance the speed and accuracy of whole building LCAs and provide the real-time data needed to support sustainable product design and, of course, ultimately, the smart use of our materials. That's all I have, Kate.
Thank you so much, Jennifer. Oh, I'm sorry, Laurel. Thank you so much, Laurel.
Yep.
I'm transitioning now to Roderick. Roderick Bates is a principal and researcher at Kieran Timberlake. He brings to market the technology developed by Kieran Timberlake, managing the transition of internal bespoke tools to those capable of being used by the greater design community. Roderick interprets ecological, economic, climate, social, and site data to inform sustainable building design and assists architectural teams to envision design modifications to improve a building's energy performance and thermal comfort, leveraging novel tools to generate actionable information.
It's all true. Thank you, Kate. I appreciate it. So with that, we'll go in and show you the Tally software. Go to the next slide. So this was our vision. What you see on the top there, traditional workflows, what we had started to do from a life cycle perspective in the context of our firm's design practice. And we found that while the information we generated was great, it took a lot of time. And that time prevented the information from feeding back into the design process. So we envisioned and then created a tool that allowed for a couple of things. One of the key things was that it allowed for iteration in the context of life cycle assessment. And iteration was possible because we designed a tool that was thoroughly integrated into the modeling platform that we, as designers, were using throughout our office, which was the Revit BIM platform. In addition to that, we also realized that a lot of different people on the design team have information that's relevant to conducting a life cycle assessment. So what we did is we provided through BIM integration, a mechanism by which anyone accessing that model, whether they be linked models, cloud-hosted models, what have you, accessing that BIM model was able to access that LCA data, also input LCA data, and make decisions that were relevant using that life cycle assessment information. So this was our vision and what we've created with Tally. So go to the next slide. So a key part of Tally's functionality is the fact that it represents a collaboration between several entities. One of them, of course, is us, Kieran Timberlake, and the sort of the technology subsidiary KT Innovations. You know, we're first and foremost a design firm. We are a firm full of architects as well as researchers, computer programmers, things like that, as well as LCA experts. So we were able to bring an understanding of how people actually model in the context of BIM when we designed our tool. We know the standard conventions of BIM. We understand essentially how a BIM model is not necessarily an accurate reflection of an actual building design. So how to reconcile those differences was core to our expertise. Also, of course, the Revit software is a fairly complicated software, and deep integration requires a deep understanding of the Revit API. So in the development of this software, we partner with Autodesk because obviously they're the ones that developed it, and they understand the method to the madness. And then, of course, ThinkStep provides the LCA data specifically. LCA data, as has been said several times in the course of this particular webinar, it's complicated, and it's also changing rapidly. So by partnering with ThinkStep, which produces the Gabby software, we were able to have a custom database generated just for Tally that we know is of the highest quality. Next slide. So one of the key things in the context of Tally is reconciling this difference between what's modeled in BIM, which you see there on the left, that's actual screen capture of a wall assembly, and then what's that going to look like when it's actually built. As you can see, there's far more complexity in the built final product than is ever modeled. And a lot of that's made up for in specifications and just understanding on the part of the contractors. But that doesn't mean that that information shouldn't be accounted for to create an accurate whole building LCA. Next slide. So through the Tally interface, one is able to pull from that Revit model a bill of materials and then link that bill of materials to a particular LCA entry and add the additional metadata that allows for that accurate quantity takeoff. So you'll see in this particular example here, looking at the brick, you may just have that brick layer in Revit, but of course there's also going to be grout of a specific mortar type. There'll be reinforcement rod, things like that, a different actual brick volume. All of that could be specified in the context of Tally, and it doesn't have to be modeled in Revit, which of course it never would. You can also note too that some things can be marked as existing or salvaged. So if you're working on a building that's recovered, that could be noted as well. Next slide. So here's just another example of something where it's actually just completely absent typically from a BIM model, and that's your studs within a wall assembly. So that's something where Tally would recognize that even though there actually isn't something modeled, it's just sort of a void space, you can actually specify that there's studs in there, what their spacing might be, things like that. So the level of metadata you can apply really accounts for all those things that just as a matter of practice aren't modeled within a Revit model, and of course those that are. Next slide. So once you have all of that type of information linked back to those materials, one can run an assessment, and we offer a variety of ways in which that assessment can be scoped. You can decide what to include, whether it be a whole building assessment, and you can also include linked models or not, and things like that, so you can bring in a variety of work sets that really reflect the complexity of a contemporary large BIM model. Next slide. And of course, in Revit, there's the design option comparison capability that's frequently used by designers when they're trying to decide between various options as they go through the design process. So we leverage that as well, allowing for a direct LCA comparison of design options if you have those populated within your Revit file. Next slide. One of the things that we really bring to the table as designers, I think, is a critical eye to the aesthetics of the output reports. This is something that we probably belabor our PowerPoints that we put in front of clients far more than we should. But at the same time, we realize that graphic quality is incredibly important when it comes to communicating information, particularly something as complicated as LCA data. So the output reports from Tally come in two formats. One of them is a PDF report that has fairly high quality graphics that can just be captured and put directly into presentations. In addition to that, it also includes Excel file that really includes every little piece of data that Tally generates. So for those that really want to get into the weeds, that more sophisticated level of information is available as well. Next slide. So something like Tally, because it's integrated into Revit, really allows for rapid assessments, and you can use it at any stage of the design process. Essentially, if you can draw it in Revit, you can run an assessment. So something as basic as just looking at a functional unit of a cubic yard of concrete and running a variety of either preset mixed designs or even custom mixed designs, looking at various levels of substitute cementitious material. Next slide. And one of the things that we've been finding, at least internally, is the impact of just looking at various coatings on particular metal finishes. So we found that this can be incredibly impactful. And some of our recent projects where we found like we're using fluoropolymer coatings or anodized coatings in particular are ones where we just simply hadn't realized the scope of this, and being able to really pick and pull out these individual pieces and run these rapid assessments have opened our eyes to the impact of some of these materials that are otherwise really under the radar. Next slide. So while those are looking at really sort of finite comparisons that one could do fairly early on in the design process, or even quite late if you're looking at coatings, something that we found, if you take that scale and apply it actually to something much larger, which in this case was a reuse assessment. So this is actually our office. It was an old bottling facility that we purchased, and we're really wondering about the benefit of reuse versus building a new building. Obviously, reuse comes with a lot of challenges when it comes to actually how do you pull that off from a design and construction perspective. But performing a life cycle assessment on that showed, if you look at the next slide, that through the use of Tally and very easily being able to mark certain things as basically being salvaged, we were able to run this life cycle assessment where we found that through the retrofit, it was a dramatic savings, and a lot of that came down to the fact that this building, we're saving the structure, we're saving the majority of the envelope. That really adds up. And so being able to run these rapid assessments provided the evidence to us of those benefits. So if you have any questions, feel free to reach out to us. We make ourselves very available to everyone, and you can just call me right there. And well, if you call me in 15 minutes, you get to talk to me personally. So thank you very much for your time.
Wonderful. Thank you, Roderick. Now I'm introducing Stacy Smedley. Stacy is the Director of Sustainability at Skanska USA Building. At Skanska, Stacy leads the sustainable initiatives and is progressing sustainable construction methods. Stacy is also the co-founder and CEO of Seed Collaborative, creating environmental restorative learning spaces that educate and inspire. Stacy?
Great, thanks, Kate. I'm the closer, so I'll try to talk quickly to help us end on time. Again, my name's Stacy. I'm with Skanska, and Skanska is, first, just to give a little background, an international contractor. If you go to the next slide, with 36 offices in the US and our headquarters based in Sweden. And as a firm, as an international company, we have 2030 and 2050 commitments to deep carbon reduction related to how and what we build, both in construction and in the materials we procure and put in place. This has led us to focus on the embodied carbon of materials specifically, and how per material category we can drive associated emissions down to allow procurement choices to include emissions in vendor and manufacturer specification and selection. So if you go to the next slide, we are currently co-creating an embodied carbon and construction calculator in partnership with the Carbon Leadership Forum and support from our client Microsoft. Microsoft's a funder and a pilot user on their Campus Refresh project as we start to develop this and see how it can be applied to a real project. You'll hear me call it EC3 as we move forward. So if you go to the next slide, we are a contractor, and we know that for any project with an estimate by any contractor, we have material quantities that are organized in what you see here in this uniformat standard. So as we develop this EC3 tool, the inputs are currently based on this format as an organizer. We think that the contractor's estimates with the quantities that we have are one of the most accurate sources of quantity data based on the fact that we're putting costs to them, and contractors want to make sure that our costs are accurate. Therefore, the quantities behind those costs are as accurate as we can make them. If you go to the next slide. Autodesk is also currently working on a plugin to BIM 360 for us, where we would be able to also have our emissions data around material choices linked and live in BIM 360. So that's an exciting development for us recently. If you go to the next slide, EC3's data, because it is focused specifically on material specification and vendor selection, is based in EPD data, looking solely at the global warming potential or carbon emissions that we can get from those EPDs. And this is just how we explain that. You know, it's like we have the declared unit as the serving size and the climate change or global warming potential with the carbon emissions as the total carbohydrates. So that's really what we're pulling out of our EPD database to get to the emissions factors we're currently looking at. If you go to the next slide, part of the data research for the EC3 tool includes a partnership with the Carbon Leadership Forum in creation of material category reports per material, and you've heard about this in previous presentations today, that really act to daylight current variability and EPD comparability, and assign a variability to that data that we're putting out there. And our hope is that by doing this, we are producing these reports to incentivize further work to make EPDs at a higher level of comparability per material category. So that will be a part of what we are producing and putting out there in terms of reporting for the tool. If you go to the next slide, one of our key components of EC3 is the EPD database that we're developing, which is an open source database with an open API. This is just a screenshot of the concrete EPD database for EC3. And what that means is that anyone else can go into the database and sort and select and download EPDs for their own use, and can also take our API and our associated data factors around emissions and use them however they want to in their own tools or for their own purposes. And that's really important to us, that we're creating something that's open source and available to others to use. If you go to the next slide, for our own purposes, we are setting our benchmarks for baselining relatively high when we're taking that global warming potential information out of the EPDs. And that's really to incentivize manufacturer disclosure. If they know that they're being compared to a higher baseline, they might be more prone to creating an EPD. And that's also to get projects to start to look at benchmarking and reductions against a baseline. And we want them to realize reductions. So this may become a lower baseline. It might move down as we get more accurate with data and we have more folks in the system. If you go to the next slide, I'm just going to walk through quickly where the tool is currently. It starts with the building planner page where you can actually start a project in the system and put in any information about the project that you wish to disclose. Next slide. You can also look, find and compare materials. This is just an example of the concrete category where you can filter by state or province to get just your local suppliers if you wish. Put in whatever information you currently know about your material in terms of performance data, and this would be applied to any material that you're looking at in the system. And click search, and what that does is allow you to see the number of EPD samples in the database that meet your sorting requirements, as well as, like I mentioned, the conservative and achievable estimates based on the global boring potentials that we're averaging from those EPDs. Next slide. Just a little bit in terms of the next step, if you want to, based on the EPDs that meet your requirements, you can then sort those EPDs by all of these things that you see, including global warming potential. Click on that to get more details from the EPD, and then download that EPD for your own reference if you wish, straight from the tool. Go to the next slide. We're almost done. This is just kind of the whole process. Again, we're taking quantities mainly from estimates. We also have engineers and designers testing this for us in terms of their own quantities. Give those the names that you want to in terms of the descriptions from your estimates or projects. Apply all the materials that you want to look at, and then again, look at your building in terms of this snapshot of just the embodied carbon emissions of the materials that you've selected based on the EPDs in the system. Next slide. This is just a kind of a blow up of that. And again, we're setting these kind of high and low embodied carbon thresholds based on the EPDs that we have for the building, and then all the way down to the materials. Just an example on the left for rebar for this project in Washington. There is this variability in the rebar, and we know that the Washington produced rebar is down at that lower level. So there's something that we would be able to claim on this project. Next slide. This is kind of the next iteration of the graphics that will be available as we develop the tool. This is looking at our 3 concrete suppliers in Washington and the EPDs we have associated with them. And again, allowing us to understand per PSI mix what their range of emissions are for the mixes they have EPDs for. And based on the details of those EPDs, start to make actual performance spec choices and procurement choices around cure time and SCM quantities based on what we know is possible in terms of the data that exists. Next slide. And just one more example, looking at, again, the steel or the rebar locally, because we have these EPDs for our suppliers in Washington, being able to actually see where they fall against the industry average and know that by procuring locally, we're achieving that emission savings. And looking at gypsum board, again, per manufacturer, starting to understand per type of gypsum board what the variability is in their current products and how we can actually specify and select based on emissions. Next slide. One more just to kind of wrap that up. Our goal is that we would then work with our design teams to be able to specify things based on this information, put it into our specs with global warming potential maximums or particular products based on this information, and then get it into our contracts in procurement. So we're following through and actually installing those items and realizing those savings. Final slide. So the EC3 tool right now is, again, being piloted on the Microsoft project, or we're putting it on a few other projects as pilots. We are hoping to have it publicly available for anyone to use freely from our website in 2019. And again, the data, it will be downloadable as an open source API. And this is just a list of the current manufacturer, supplier, organization partners.
Great. Thank you, Stacy. And thank you, Jeremy, Jennifer, Penu, Laurel, and Roderick for joining us today and sharing your knowledge and insights. So a few reminders before we move to question and answers. We'll be here for the next 15 minutes or so. If you are an AIA member and you want credit, please email to the email address on the screen with your AIA number and full name. And if you missed any of the previous webinars, you can visit our website to get access to the session recordings. And stay tuned, because in early 2019, we'll have information about the next round of webinars. So let's see. I look at some of the questions that we have. I want to start first with one for Jeremy. So I personally am quite excited about the announcement of the Canadian LCI database. And I wanted to ask you if you had recommendations about how stakeholders might participate in developing a better background data, and particularly getting a unified North American database.
Sure. Yeah, that's an excellent question, and one that we're actively working towards because I think that the effort that I mentioned that was just recently announced out of Canada, they also see opportunities to expand it beyond Canada and certainly have it be harmonized across all of North America. And so right now, I've been leading the North American Lifecycle Inventory database effort and have an email list and a group of stakeholders who have been involved in shaping that. And what I'm doing now is having conversations with Jeff about how we might merge both of those, because either way, they both need stakeholders involved for helping to shape it and also helping to fund it. And so basically, if people are interested, they can send me an email and I will include them in our stakeholder list that we'll be tapping into here in the next few months to try and move these things forward together.
Thank you. Do any of the other panelists have comments on that topic? Okay, well then I'll go to, there are several questions along the same lines. There are many resources and tools available, and it can be confusing and time-consuming to weed through all of the intricacies for someone trying to make a choice. So the question is, what's the recommended method of proceeding for a firm that's just embarking on this journey? So I think I'm going to ask Jennifer to start with a response to that. Do you have some recommendations, Jennifer?
Oh, thanks, Kate, for a hard question.
You're welcome. I'll help you out too.
I'm sure you have some thoughts. Well, and again, Athena's not a software company. It doesn't really matter to me whether folks use our tool or not, but it is free, so it's not a bad place to start. Having said that, I think it's pretty cool that Tally's a Revit plugin. And so, for folks that are already working in Revit, why not start there? I think either way, though, a little bit of fundamental education is probably a good idea. If folks want to start with maybe an online course, just to get the basics of LCA first, I think that's what I would recommend.
Okay, and I'll add a little bit to that. The Carbon Leadership Forum published an LCA practice guide, which is designed to be an introductory level. So there's sort of a first chapter that's big picture, and then a second chapter that's more about implementation. And there are other guidance documents on other different tools. I would not be too concerned about how to start. I would recommend starting. So if as Jennifer mentioned, there are free tools that are available, or if you have some resources, it's worth trying one of the different tools. And the first step is really to start to understand the process of life cycle assessment, understand what types of data that you can get out of it. Are there others who would like to add to that?
Yeah, I could suggest trying to start early in a project, so that's when you can really shape the project. So it's not very useful to document how project is performing when every decision is taken. It's valuable to shape the project. That's, I think, what I could suggest to try to aim at, and working in that way.
And
I think
thank you.
Yeah, what I was going to say is that this is Jeremy. When we teach LCA to students, we often say there's kind of an evolution in how LCA is used, and it usually starts with just kind of like exploratory or trying to just understand a bit more of the implications of different design decisions on environmental outcomes. And then the next step would be actually more formally supporting design decisions. And then probably the last one would be reporting publicly. And so with each one of those, it gets more important, maybe which data and tools that you use. But certainly for that first one, where you're just kind of exploring different concepts, I don't think it really does matter. And so, as you said, just kind of starting out with that education and measuring some of these things and seeing what happens, it really doesn't matter.
And I've seen a great example where a firm looked at standard wall assemblies. So rather than looking at an entire complex building, they looked at standard exterior wall assemblies and modeled them and compared them. So breaking off a smaller chunk of a building makes the analysis easier to get into. So let's see. Let's see. I'm looking through the questions here. Let's see. I have a question to Roderick and Jennifer. With whole building LCA tools, is there how do you incorporate supplier-specific environmental impact data into your tools, or is there possible to do that?
I'm happy to answer, but maybe Rod wants to go first.
Sure, I'll go ahead. So I'm assuming you mean EP, or that individual is referring to EPD data as being supplier specific or manufacturer specific. We do include that if it is an EPD that was generated or reviewed by ThinkStep. Essentially, we want to make sure that everything in the database can be compared to itself. So obviously, something within the same PCR is relatively easy to do, but let's say you're comparing something that maybe like a wood frame building to a steel frame or something. So there's obviously very different PCRs, and you want to make sure that you have basically comparable data. So we typically review that information and incorporate it. We have a number of manufacturer specific, and we also have a number of industry specific EPDs, but we're always looking for more, to be perfectly honest. And so on certain projects where people find something that they want to have and it's not in there, then we basically communicate with the manufacturers and work to get that data in. It can be a lengthy process if they don't even have an EPD to begin with, but sometimes it can actually be quite quick if they have an EPD and it was already produced in Gabby.
Jennifer?
Yeah, okay, thanks. For the impact estimator, we primarily rely on industry average data, and that's because if you're using LCA during design, you likely don't have the manufacturer-specific data yet in hand, so the industry average actually makes sense. However, we do have an opportunity to incorporate manufacturer-specific data when it is requested of us to do so, and we have a few in there right now, and we keep adding more. If we're requested to do that, what we need though is we need the underlying full LCA report, because we're not comfortable with the level of detail available to us in an EPD. But I agree with Rod. It's a bit of a process to include that.
So I think there's a parallel question to Panu and Stacy. So could you provide a little bit more detail on the processes you undertake to ensure EPDs are comparable when they're incorporated into your tools? So could we start with Panu?
Yep, great. So we have a data quality assurance process, which has been developed together with Building Research Institute, BRE, basically, and who have verified the process, and we implement that process. And we do give actually the users a choice to choose the data domain, basically, what kind of data they want to use. So they can choose one kind of data or other kind of data. And once they stick with the data domain, basically, all of it is uniform. That's how it works. Of course, we do have to turn down some data, but we have a very strong LCA data engineering team. So what we can sometimes also do is we can repair some of the data, for example, to harmonize biogenic carbon storage handling. So in some cases, we can repair data which is reported in a different way, but not always. But pretty much 95% of the time, we can integrate data if it's third-party verified EPD.
And Kate, I'm just going to actually defer to you because you are our specialist in this when it comes to developing the material category reports and the variabilities that we're building into the tool, if you don't mind. I'm not.
Nope,
I'm not.
Yep. So the EC3 tool is in development. And right now we are actively working with structural steel and reinforced concrete in terms of defining and understanding the background PCRs and upstream data. So when we will be developing, where we are in the process of developing, and we'll be including, as Stacy mentioned, some variability factors to account for known variability of upstream data, which in concrete is low and in steel is high right now, into the tool. And we will be looking forward to getting feedback from others on that methodology, and hope that we drive towards better data, both in the product category rules and in getting a unified LCI database. I think I have one last question that I know we're at time, but I'm going to ask it just because I think it's a really good one. So Architecture 2030's Carbon Smart Material Palette highlights several carbon sequestering materials that currently don't appear in any of the tools discussed today. What can the Renewable Materials Task Force provide to ensure that these important, rapidly renewable, plant-based, and ultra-low carbon materials and systems are featured in your tools? Is there anything we could do to help that data be in the tools? I'll start with Jen.
Well, we need an LCA report, and then.
So,
that's
would you need a peer-reviewed?
Just LCA with accessibility to the inventory data.
Any other suggestions?
Repeat the question, Kate. That was just the last.
How to get the alternative low materials, low carbon, carbon sequestering, or innovative materials. They don't have data, so they may not have an industry trade organization that's funding the LCA. How to get them into the tools?
Yeah, I think it is. We need that information, but I think it's also how we start to get funding for those folks to do it, right? So it's the underlying support coming together to support that need, and how we can leverage industry to actually fund some of those things. I think we know what we need. We just have to figure out how to help them get there, right?
Yep, good suggestion.
Another point, there may not be like straw EPD for North America, but manufacturing straw is not that different in different parts of the world. So we do have a global database, and that can be used for carbon. It can't be used for combining with lead LCA, because the characterization methods in global data sets are slightly different from North American, but some of these do have carbon data in international data sources, and some of it may be available. So I just looked up straw. That's what came to mind.
Great.
And we have it.
Well, thank you very much. We will end the webinar now. It will be posted by the end of the year online, and you will be able to share it with others. Thank you very much for our presenters and participants, and we hope you have a good day. Thank you.